Hi and welcome to Terex Bench. Today on the bench, again, the Bosch KF166, which we converted in video 191 into a ham radio. And this radio was especially converted into a ham radio because it should be used on a repeater. And no, this radio does not make any trouble, so it is still working excellent, no problems at all. But every now and then conditions are changing, and you all know that sometimes, depending on the repeater you're using, you need a tone frequency to get access to the repeater. And well, you may remember that we have here a tone code board in which was used as this radio was used for business services. And that is a kind of tone squelch. That means that if different organizations on one frequency, then you can put it to silent mode, and if somebody wants to talk to you, he needs the tone code to open your tone squelch, and then the stations can talk to each other. But that is not needed, of course, for ham radio purposes. So that board, and it is still in, is really senseless for this use. And on the other hand, if you are using it on a repeater, some repeaters really need a tone frequency. And the tone frequency in Europe is 1750, right, hertz. And that is the tone you need, what you need to send out to finally open the repeater, or yeah, you finally get access only with sending out this tone. And of course, the operator or the owner of the relay or repeater, however you want to call it, can decide if he wishes to let the access by simply pressing the PTT button, or if he or she is requiring a tone. And yeah, as I said, the circumstances has changed a little bit, so now we need a tone to get access, and therefore this video is about how to install an external tone frequency for opening repeaters. Well, and in the past we really needed it more often to convert radios like this into a ham radio, and then of course we needed to implement this tone frequency to be able to open the relays. And there it was, back then, at that time, it was very common that you needed a little circuit which is producing your 1750 tone frequency. And yeah, so that was nothing special, but a lot of time has passed by, and we really do not convert these radios very often into ham radio equipment, and therefore I had almost forgotten how we did it in the past. But I am so lucky, I have a great community and one fellow radio operator, so he is as well a viewer of our channel, and he supplied me with his old circuit diagram to simply produce a 1750 tone. And yeah, it is a CMOS IC, a CD4060, which is a very common IC. And well, it is nothing but an oscillator which is integrated. So we only need 2 or 3 additional parts to make the oscillator running. And then it is nothing else but, you know, it is simply a divider or a counter. So that is really very, very simple. So by having dividing our input frequency, we can get the needed frequency out of it. Oops. So that is, you know, the whole story. And maybe if we watch this little diagram here, we can see how really easy it works. So the internal oscillator of the 4060 can be made to oscillate by just connecting a resistor and a capacitor to pin 10 and 11. Or we can also use a crystal, or finally we can use a ceramic resonator. And then when the internal oscillator is working by the crystal frequency at least, then finally you can see we have here different outputs, and very easy. So the frequency which will be generated in the oscillator will be divided by all these functions you can see here. So that is all what it is about. Yeah, and back to our schematic, you see that we have here our ceramic resonator. We have 2 capacitors, and that together is creating finally our oscillator. And yeah, these ceramic resonators are looking like this. And when we go closer, I hope you can see it. So that here is a 455 kilohertz resonator, which will oscillate together, of course, here with our internal circuit in the 4060 with finally 455 kilohertz. And now, as I said, we have a divider, right? And when we take our clock of 455 kilohertz and we divide it by 256, then we are at pin 14, right? Pin 14, which is Q8, so output 8. And Q8 is our oscillator frequency divided by 256. And then we simply get here at pin 14, which is this here, we will get nearly 1750 hertz to be able to have our tone frequency which is needed to get access to our repeater. So that easy it is with 4060 to create simply our needed tone frequency. Okay, and that means as next step I will produce this little circuit, which is really very simple. So that circuit will definitely work. The only thing I have noticed, I guess we need here a resistor between pin 11 and 10 to make the circuit work. As far I have it in mind, we need to have here, I don't know, something 2 mega ohm, something like that, to make the circuit functional. But other than that, that is all what you need. So let me produce this little circuit, and then when the circuit is ready, we can do some experiments with it. So we connect it to a power supply, and we want to monitor here our output, and yeah, we simply want to see if we are really able to achieve our 1750 Hertz, which is needed, right? Okay, enough talking, so let's come to something much more exciting. Yeah, I have done the little circuit here, right, on a little circuit board. It is in fact a proto board, and yeah, let me zoom in here a little bit. So you see, it is really easy, nothing special. We only have our 4060, our ceramic resonator, and yeah, that's it. I mean, really not a big deal. And well, you see here underneath, you see I have a SMD component, and that is a resistor which we placed between pin 11 and 10. So going back here to my schematic, you see that is this guy here. And yeah, other than that, we have here a potentiometer which is needed to get finally the right level which we need, because remember, we are feeding here our circuit with, I believe, 12 volt. I mean, we have to test it here with our radio. I'm not entirely sure what the voltage will be, which is up here in the microphone. And depending on the voltage we get up here, we have to adjust our level. Okay, so as you can see, it is connected. Okay, we need to put finally a fixed resistor or a fixed potentiometer to the circuit, but that will be done when we are have it all running as it should. Now let's see if it really works, that we get the needed frequency out of it. All right, and here it is. So when we zoom in here a little bit, right here to the top, so you see it is 1.747 kilohertz. So now we have 3 hertz off, if you like, but that really doesn't matter. And you can see we have a nice and clean signal here. So for the moment in time, the output voltage is not 9 volt, because we have 5 volt per division, and you see 1, 2, it is almost 3 times 5, because 1 division means 5 volt. You can see it there, and that means that it is almost yeah, 15 volt, right? That is the outcome here out of our IC, and yeah, you see that we are really meeting the needed frequency, and that simply because we divide our input signal, so the oscillator signal, from 455 by 256, and that means that at the end we are meeting our needed frequency. And of course it is a square wave, it is not a sine, because it is a digital circuit what we have built here, so it is clear that we finally have here a square wave output, but that really doesn't matter, because by all the filtering through our radio we will get at the end a nice and clean sine, and that is something, of course, what we are gonna test, so that we prove that as well. But yeah, by now it is the first step is really done, so we can really go ahead with our circuit, right? Okay, so now let's do some tests that you really see that it works. So we are here at pin 14, so we are dividing by 256, but let's really see if it is true that at Q9 it is divided by 512, or Q4 it is divided by 16, and finally we have, of course, here at pin 10 our oscillator frequency, which is around 455. And so let's check if that really works as it is promised here from our chip designer. So let's go down to some of the test points and watch our oscilloscope screen, and let's see if it is true what the designer promised us. Okay, so let's see what we can do. So first of all, let's go to pin 11, which is here, and yeah, of course you do not really see the signal because we do not have the right resolution. So let me try to change it, that you see here our oscillator signal somewhat better. So let me see if I can do it for you, and yes, so you see 447 kilohertz. And you see that now it is not a clean square wave, and that is due to our setup here and to the oscilloscope itself. So it is because our testing is limited here. So that's the reason why we do not see a clear sign. But anyways, it is 447, so that is our oscillator. And now let's go to once again to our output, which we have here, and you see that is our 1.47. But let me check also pin 13, which is, let me count, so that's 9, 10, 11, 12, 13. So that is here, and I hope you can read the upper display, which is telling us the frequency, and I'm reading 873. So you see that is obviously divided by 512, and if we go here to pin 6, which is here, you see we have 3.49 kilohertz. So what you simply can see, and yeah, if I go down here to our circuit, it is really nothing else and simply picking here the signal at the different outputs here, and by simply using here different outputs we can finally change the frequency, and that is really the beauty with this IC. So you really can use it for a lot of applications, and that here is only one application, right? Okay, so for testing I have now connected here my potentiometer in the right way, so that I can adjust here my input voltage, and I can demonstrate it here. So watch here this display here, so that is volt peak, and it is at 680 millivolt. And let me show you that I'm now able to adjust it, so that are my fingers, so the distortion you see. But I just wanted to show you that I'm now able here to adjust finally my output, and that is very important, because you can surely understand that we cannot drive our audio voltage, because finally that will be an audio voltage which goes over our microphone audio line down into our radio. And you may believe that we cannot drive it with, I don't know, 15 volt, because I'm supplying here our circuit with 13.2 volt right in the moment. So as I told you, I do not really know what the voltage will be which is present at our microphone, and it depends on the microphone. If the voltage on the microphone is at least our supply voltage from our car battery or so, then of course our output voltage is much higher and we need to reduce it. So depending on what we really have at our microphone, we have to adjust our audio level, and that is what it is all about here. Okay, we need to check if at least the impedances are working, but that is not our biggest problem, because really we can adjust it a little bit, or as we need it. And because you may know that normally microphone input impedance is approximately 600 ohm. It depends always a little bit, and therefore maybe we have to play here a little bit. But important is that our input level is not too high, because then we would simply overdrive our input audio stage, which really is no good idea. So therefore it is important, and that is what we have done here, right? So you see I'm really able to bring down here my input voltage. Where are we now? Volt peak is at 300, what is it? 32. I'm so far away from my scope screen that I really can't read it. Anyways, so that is positive testing on our build. Now let's go into the radio, because of course we have to prepare our radio that we can feed this signal in our or on our microphone audio line. Okay, so I'm making progress. So as you can see, I have shortened here the proto board in order to get it here into the microphone housing, and I have added here my variable resistor, so my potentiometer, right? And yeah, so normally now it should be possible to get it here into the housing. Also there is really not much space, since we have here our PCB, which is covering here our entire enclosure. So yeah, it is a little bit tricky. So we have a little bit space here, which should be finally okay. Yeah, what do I need else? So as I told you, I just want to use here the yellow button for the tone frequency, our repeater call. And therefore, I mean, it is, let me go a little bit closer here. So that is one of these micro switches here. What I probably need to do is I have to unsolder it, and I have to take them out, as you know, I need to disconnect the old traces which are going here to the switch, because of course I do not need them any longer. So that is what I need to modify, and what I've modified as well. So I had here sitting a little transistor, so this one, and as far I have seen it on the schematic, so that is only to deliver voltage here for this LEDs, but we do not need this LEDs any longer. So I've taken this transistor out, because that is not really helping to get here my PCB into the housing. And what I've seen in the schematic, so voltage which will be present here at our microphone is, according our schematic, 5.5 volt. So of course we have to double check it, and I've set here my power supply to 5.5 volt to have finally the right condition here at our tone board. And of course I'm monitoring here my signal with our 5.5 volt, and I've set here my I've set my potentiometer to 300, what is it, 70 millivolt. So that will be our starting voltage, and we want to see if that is a good voltage to have the right values, the right levels, so that we do not overdrive our input stage, and so forth and so forth. So the next step I have done is I have terminated here our output, our tone board with 620 ohm. So normally we have, as I already said, 600 ohm impedance, which is the input impedance of the microphone input in the radio. And of course, to be sure that we still have enough output voltage, we need to terminate our output with approximately 600 ohm, and that is what I've done here. And under this condition, I mean, now here my potentiometer is quite high, so that is 500 kilo ohm. So maybe it is a little bit too much, especially because I've already a 270 kilo ohm resistor in front, so the one which you can see down there. So that is now in line with my potentiometer, and that means 270 plus 500 500k in line, and that means that when I go now and terminate it with 600 ohm, then you know, you have a real mismatch here, and therefore it is important to see what the maximum output will be when we terminate it with 600 ohm. And that is what I'm displaying on the screen. Yeah, and that is what you can see down there. So that is a peak level, and you see it is approximately 160 millivolt. So normally that should be fine. So I cannot obtain more with the configuration I have here on board right now. So therefore we need to check if this 160 is fine. I mean, this is a electret microphone, and we have a little transistor audio amplifier in line. No, it's not an audio amplifier, that is what I just see. I'm looking here on my schematic, so that is more it is more impedance converter, whatever. Anyways, so what we need to check is if this 160 millivolt into 600 ohm is efficient to have our loud and clear tone. If not, I have to reduce here my potentiometer maybe to, I don't know, 200k, I don't know. We have to check it. So next step is I have to wire it up to our microphone, and simply we want to check then as next step the little circuit in the radio or in the microphone, whatever, in the combination microphone radio, to see if all the levels are as we need it. Yeah, I have double checked here our service manual, and you can see here our microphone amplifier, and the service manual is telling us that the microphone amplifier amplifies the AF input signal from about 1 millivolt by 60 dB to approximately 1 volt. So that means that most likely our configuration here is good, but finally we will see it when we do our first our first test on a real circuit. All right, real circuit testing. So that is what we have wired up here. So our radio itself is receiving. So you hear our test tone on our frequency, right? And what I have done here so far is that I have connected here our little circuit to the radio. So we are coupling here our 7050 Hertz into our circuit, and here I have put in a switch where we can activate here our little tone circuit. And now we need to check if it works together. Okay, so you see our Roto and Schwartz is working as a generator, and now when I push our PTT, which I do now, so what you see is that we have our 11.7 watt, and that is what we adjusted it for. So going on transmit, so you see there TX test, so that is our output power, and here is our output frequency, and yeah, so we see everything seems to be fine. Now let me activate our little generator by pressing here the button which I've installed to engage the circuit, and let's see. Yeah, so that is really nice. Let me see that I can increase here my tone. And so what we see here is that we have a nice sine, and what we see as well that the counted tone is 1 point. Okay, let me go down, and you have here our counter, so you will see here our counted frequency, and here of course you see the audio. So let me once again activate here our little circuit, and you see the counter is counting for 1.747 kilohertz. So that means we are 2.5 hertz off, which is fine, no problem. So the relays will be that tolerant to allow 2.5 hertz frequency error, and you see our audio sign on, yeah, you have seen it over there, and that is telling us that obviously our circuit is working just fine. So you see as well that we do not have any longer a square wave, so it turned into, finally, let me do it again, it turned into a sine. I mean, it is not crisp clear, but that doesn't matter. So you see that we have full deviation, so it will be a loud and clear tone to the repeater, and yeah, so that is telling us everything is working fine, and we really can put our circuit here in our microphone housing. Alright, so our little circuit is built in. So if you look there in between, you can see our circuit, which is glued to the little chassis here, and then you see this connector, which is here the yellow one, is wired to switch in our tone circuit, and then you see here the coupling capacitor, which is the AF from our tone circuit, which goes then our way down to the radio to be able to open a repeater. Okay, so let me demonstrate it to you. So you see our radio is receiving, so let me turn down here our audio level a little bit. So that is our receive LED, and that is our power LED in general. And of course now when I press PTT, you see that our TX lamp is coming up, right? And now when I press this here, then we get our repeater tone, right? So now I show that to you once again on our tester, so that you see how it looks like. Alright, and once again I do exactly the same what I've done before, and I have to press my PTT, so you see that 11 watt are present. Now I press the yellow button on the front, and you see that we get our audio tone to open our repeater. So everything is working just fine as it should. So now we can close here our microphone housing, and well, job is done then. Okay, so everything is back together, and yeah, just wanted to show it how it is right now. So now we press our PTT, and you see that our radio is going into transmit. Now I'm pressing additionally my tone button, and you see that really we are getting our 1.75 kilohertz tone. It is 2 hertz of, which is very nice, no problem whatsoever. So you really see that it is working just fine and as expected. Right, and that means we are really at the end of our video, so everything is just nice. I hope it is a little bit helpful for you projects as well. So thanks for watching, and catch you next time. Bye.